triangle was named after a famous mathematician. Did you guys catch his first name?
No.
Well, somebody wasn't watching. Yeah, Blaise. Yep, Blaise Pascal. Okay, so you're going to expand the powers of binomials using Pascal's triangle. That's what we're going to do today. So one thing that we can start with is that all of the outside numbers are 1. So we can put 1 on all of the outside diagonals. So this is called the first diagonal right here. Okay, and then it's going to work in both directions. Okay, and then many interesting number patterns can be found, such as the Fibonacci sequence. That's a special sequence of numbers that you'll learn about when you do sequences in series next year, or maybe you've heard of it before. I know. Okay, so the way that we're going to fill this out is we can add 1 plus 1 to get 2. It's the two numbers above it. Okay, it's the sum of the two numbers diagonally above it. So 1 plus 2 is 3, 2 plus 1 is 3. Okay, and we can keep following this pattern. 1 plus 3 is 4, 3 plus 3 is 6. Now, if I keep doing this, 1 plus 4 is 5, is there like a quicker way that I can fill in a few of these columns or diagonals?
On the second rows, you can just do 5, 6, 7.
Yeah, because 1 plus 6 will be 7, 1 plus 7 will be 8. So yeah, let's fill those in because that'll be quick. Good, and then it's the same thing here. And then there is a pattern on the third diagonal, so you got it. Okay, so as you fill this out, you're going to start to see some patterns. Okay, I'm going to give you a couple minutes right now to fill those out. Yes, you can use your calculator as the numbers start to get larger. Okay, and then I also want you to fill in answers to questions 2 through 4 below. So you guys had to find the remaining rows. Do you remember what this top row is called? It's actually called row 0. And this one is row 1, row 2, row 3, row 4, row 5. I thought they mentioned it when they talked about like the 0 plus 1 plus 0 on each side. Alright, so I'll let you know. The first row is row 0. Okay, so based on that, what's the relationship between the row number and the number of terms in each row? So in row 0, there's
There'll always be
1, and then in row 1, there's 2. Yeah.
always one more.
Okay, so one more than the row number, or is there another way you guys wrote it? Oh, yep, you can do that too. And then I had students in another hour say it the opposite way, like the number of terms minus 1 is the row number. So they said n minus 1. So either one of those are acceptable. Okay, so the relationship between your row number and the number of terms in each row, you can say the number of terms is going to be 1 more than the row number, or you can say the row number is 1 less than the number of terms. Okay. All right, and then what can you say about the relationship between the row number and the second term in each row? They're the same. Yep. Okay, and then find another pattern in Pascal's triangle. I do want to.
The diagonals.
What's that? Yeah, I didn't write anything. I just told you verbally.
The diagonals go from 1 to 12.
Okay, so for 2, I said you could choose which way to say that, and then for 3, you guys are saying that they were the same. Okay.
Diagonals going 1 to 12. That's bottom right there.
Yeah, so, okay, so your second diagonal, we already talked about that. Your second diagonal is gonna just be your row number, right? Or you can say they go up by 1 each time. Do you guys remember what they said the third diagonal was in the video? The 1, the 3.
It's the number of sides a triangle can have.
Yep, they're the they're the triangular numbers. So we'll draw that out. And then you guys may notice another pattern too. So 1 to 3, 3 to 6, 6 to 10. What's happening each time? Okay, so it's gonna be +2, +3, +4, dot dot dot. Okay, and these are also called the triangular numbers. Okay. And so we're going to draw that out. And it keeps going forever. So if you're going to make a triangle, okay, with dots, you're going to start with 3 dots. So the first row has 1 dot, the second row has 2 dots, and then if you want to add a row, it would be with 3 dots. And how many total dots would you have? No. 1, 2, 3, 4, 5, 6. Okay, and then let's add a row. So you get the first row has 1, then we have 2, then we have 3, then we have 4. Yep. Okay, so in geometry you may have done some predictions, right? Geometric predictions. Not like that. Okay, so sometimes you have like, oh, here's a pattern. You have to find the next one in the pattern. Okay, and then you guys notice something about the numbers in each row. They were what? What's sort of happening with the numbers? Well, yeah. Yeah, the 1, 3, 3, 1, 1, 4, 6, 4, 1. Yeah, they're symmetrical. Okay, so the numbers are symmetric because they start repeating. Anytime you have an even number, the ones that repeat themselves are right next to each other. So I just put the numbers are symmetric, repeating. Okay, so if you had an odd number, there was a number in the middle, but then they're symmetric. 4, 4, 1, 1. If you have a even number, then the 2 that are symmetrical are going to be right next to each other. Oh, that between the row numbers. So for your row number and row number 1, how many entries did you have? Yep. And in row number 2, how many entries did you have? Yep. So it's always going to be what? Yep. You can say the entries are 1 more than the row number or the number of terms. The number of terms are 1 more than the row number. Okay, and then, and again, you guys can say that vice versa. Yep. Can. Oh. Okay, and then, were there any other patterns that you guys noticed? They talked in the video about how this relates to binomial expansion, which is our focus today. And then if you take one of our statistics classes or statistics class somewhere, even if it's not here, you can use Pascal's triangle for probability. So way back when, like when I first started working here, which is like 12 years ago, we did some of this in Algebra 2. Now we've moved it to the statistics class. So we used to do probabilities. Okay, but we are only going to do binomial expansion. So on the back, it says, use Pascal's triangle to expand each binomial. Anytime they tell you to use something specific, you are going to have to do that for credit. All right, so when you take your quiz, it's going to be similar. It's going to say use Pascal's triangle to expand each binomial. So we've learned different ways to expand binomials. Okay, you don't have to write this down. I just want you to remember that something we've done before, if you have x plus y cubed, doesn't that mean x plus y times x plus y times x plus y? Okay, and if it's cubed, then what we would do is we would FOIL, right? And we'd find what that is, and then we'd have to do what? Yeah, you'd have to distribute the x, distribute the y, okay? Now, if you had 3, we're not going to do it like that. If you had 3, then this wouldn't be so bad. But what if you had x plus y to the 8th? Do you really want to write that out 8 times? You have to FOIL 4 times, then distribute. Okay, it'd be messy. So instead, what we're going to do is we are going to use Pascal's triangle to help us. So here's how it works. Whatever your exponent is corresponds to the row number. So if your exponent is 3, you are going to use row 3 in Pascal's triangle. And you are going to list the terms from row 3. Okay, now people always ask, oh, do you have to memorize this? Well, memorize? No, but do you have to know how to make it? Yeah. So we learned today how to make it, and if you're doing row 3, then you're always going to start with a 1 on the top, and then a 1, 1, and then a 1, 2, 1, and then a 1, 3, 3, 1, right? So it's always going to add. If you start with the 1, 1, 1, you have the 2 there, the 1 and the 2 make the 3, so this is row 0, 1, 2, row 3, okay? So what we're going to do is we are going to write those coefficients on the top, and we're going to give ourselves some room here, okay? The reason why you want to give yourself some room is because visually you want to be able to see these as columns, and if you put them too close together, that can be harder for you to compute. And we're going to do most of these without a calculator. Okay, and then the next thing you're going to do is you're going to look at the first term of the binomial. So the first term of the binomial is going to start at the highest exponent. Okay, and it goes down from left to right. So the first term, you're going to start at the highest exponent, and it's going to go down from left to right. Okay, so your first term here is x. So this is where you're looking at your first term. Okay, and then the highest exponent is 3. So you're going to write x to the third, then x to the second, then x to the first, which is really just x. And then do you guys know what x to the 0 is going to simplify to? 1. So when we do this, I'm going to start writing 1 there instead just because it's less confusing. And then you're going to look at your second term, and your second term is going to start at the lowest exponent. Okay, and that's going to go up. So what's your second term in your binomial? Y. So if I start at the lowest term, I'm going to start at 0. And of course, anything to the 0 power is 1. So after this one, I am going to just start writing 1 in the place. Y to the first, y to the second, y to the third. The last one should always be your highest exponent for your second term. Okay, now your final step is to multiply the columns straight down. Okay, so we are going to multiply each column. Multiply each column. Okay, so we'll do this together. So I have 1 times x cubed times 1. That's going to just give me x cubed. Okay, and then for the next one, you're going to have 3x squared. Y to the first is just y. Then you have 3xy squared. And then you have y cubed. Okay, so when you have your final answer, I just want you to double check. The x should start at the top, so x cubed, x squared, x to the 1, none. That's usually what I say. 3, 2, 1, none. And then from the back, the y's, 3, 2, 1, none. Okay, so just double check that you have your variables there. Okay? All right, so now we're going to do this with part B. So this time you have 5. Okay, so we can look at row 5. We can also just continue. And you should always know like your first 2 terms, right?
1.
Yeah, 1 and whatever your exponent is. So I have 1, 5, 10, 10, 1. So again, space this out. It does make it easier. 1, 5, 10, 10, 5, 1. Did you have that? In row 5. Okay, and then again, you're going to look at your first term. So our first term is x again. So I'm going to start by writing x to what power?
5.
The 5. And then it just goes 4, 3, 2, and then for the 1, just feel free to put x. Anything to the 0 power is going to be 1. Okay, and then I want you to think about what your second term is and then how you're going to write that. Okay, so what do you guys think the second term is going to be?
1. There's no y. There's no y.
Okay, that's what people wrote last time. I let them write it, and they did write the y. So the reason why we use y here is because it was there, but you have your 2 here. But see how you have the negative in front? So you are going to take the negative with it. Now, negative 2 to the 0 is just 1, and then negative 2 to the first is negative 2. For these, make sure you put them in your parentheses. When you start doing these on your own, if you want to simplify them and just write the simplified one down, that's fine. Okay, I usually write them underneath. Okay, but you do need to make sure that you have your parentheses because it means something different without it. So like negative 2 to the first is negative 2. Negative 2 squared is 4. Negative 2 cubed, negative 8. And then can you guys see what's happening? What are you doing to get to the next number? Multiplying by negative 2. So negative 8 times negative 2, 16, negative 2 to the 5th. Okay, so now when you're multiplying, this is going to be a little bit easier. So this is one that you would have to do without your calculator, so that's how we're going to practice it. So 1 times x to the 5th times 1 is x to the 5th. 5 times negative 2 is negative 10, and then the x to the 4th will go behind it. So I'm going to multiply 10 by what in this column? 4. Yep, so you have 40x cubed. This I'm multiplying 10 by negative 8. Good. 5 times 16. Do you guys know what that is?
What, 32?
The 5 times 16. So you can do 5 times 10, which is 50. 5 times 6 is 30. Put them together. 80. and then 1 times negative 32. So we're doing exponents, and then we're multiplying. Did you square everything? Cube it? 2 to the 4th, 2 to the 5th? Oh, here? Yeah, so 10 times negative 8, and then 5 times 16. Okay, now for example 3, we're still using Pascal's triangle, but notice here that you have coefficients for both. So you have 2x and negative 3y. Okay, so this is to the power of 4. So if it's to the power of 4, we have to find the 4th row. And again, we always know what it starts with, right? It's going to start with 1 and then 4. Yes, 1, 4, 6, 4, 1. And again, I like to give myself space. I know I keep saying that, but I really do think it helps you visually. Okay, and then can you guys write what your next row is according to your first term? And we are going to simplify that after. Okay, and I'll cover and help you if you guys need it. Okay, so when you're writing this out, you do need to include your parentheses here. So if you don't include the parentheses, it does mean something different. And then when you're doing this on your own, you can really decide if you want to simplify. I thought some of you already did that. Like if you want to simplify in your head that 2 to the 4th is 16, you can do that. Like you could just write that out. 8x cubed, 2 squared is 4, and then you just have the 2x and the 1. Okay, but for your homework, I do have to see like your rows, each row. Okay, and then this is a negative 3y. So negative 3y to the 0 is 1, and then you just have negative 3y to the 1st. But then here we have to make sure we include our parentheses. Okay, and then I'm just going to show you how you can use mental math to help with some of these. So we know negative 3 squared is 9, so you guys are good at that. Negative 3 cubed, negative 27, we're good at that. And then if you're doing 27 times 3, you could do it like that. You can also think of it like this. Okay, negative 3 to the 4th is the same thing as negative 3 squared times negative 3 squared. If you think of it as negative 3 squared times negative 3 squared, you know that negative 3 squared is what? 9. So it's really just 9 times 9, which is 81. So when you start thinking about it like that, it's going to be easier for you to remember that negative 3 to the 4th is 81. Okay, and that's because our rule is if you're multiplying with the same base, you add the exponents together. That's why you're able to think about it like that. So now we're going to multiply straight down. Okay, so we're multiplying 1 times 16 times 1, which is 16, and then I have x to the 4th. Okay, for this one, sometimes what I do is I'll circle the numbers I'm multiplying. So I'll circle 4, 8, and negative 3. So a positive times a negative, I know that's going to be a negative, so I might write that down first. And then 32 times 3 is going to give you 96. And then you'll have x cubed y. Okay, and then here we'll multiply 6 and 4 and 9, so this is going to be a plus. So I might multiply the two biggest ones first. 6 times 9 is 54. And then multiply by 4. And then this is x squared y squared. Okay, and then here you have 4 times 2 times negative 27. So that's going to be a negative. So if you're doing 8 times 27, okay, and you can set it up like this. You can do that part in your head. 56, carry the 5. It's nice when you get down to the end and you have those ones there. Okay, so this is going to be your final answer here. And again, make sure you're checking if you have the two variables, x to the 4th, x cubed, squared, 1, none, 4, 3, 2, 1, none. Okay, so like I said, most of these we're doing without a calculator, but for B, we are going to use a calculator because your numbers are going to be very large. I know, but this one's doing with a calculator. Okay, so this is going to be the 5th row. And then if you just want to put a little note, you can use your calculator for these. And I will tell you which ones on your homework are no calculator. It's about half and half. So 1, 5, 10, 10, 5, 1. Okay, so for this one, 7w to the 5th, you can write it just like this, 7w to the 4th, 7w to the 3rd, squared, first, 1. Okay, and then we're going to go the opposite way. If you want to write down what that is simplified, you can leave yourself some room. I'm going to show you how to do it on the calculator as well. So the 4z is to the 1st, then it's to the 2nd, then it's to the 3rd. Oh, so it doesn't look like a 2. Yeah, so for the z's, I'll always put a line so I don't confuse it with a 2. That is something common that you'll see happen. Okay, so with some of the bigger numbers, I understand that that's kind of a pain to write out if you're using your calculator. Okay, for this one, it's a calculator one, so you can just do 7 to the 5th there. Yeah, so let's start over here. So we have 16,807 w to the 5th. Okay, so then when you're doing this one, you have 7 to the 4th, right? You're multiplying that times 5, and you're multiplying that times 4. So then we have 48,020 w to the 4th z. Okay, so again, we can do this in our calculator. So I would start with the 7 cubed, or you could even do 7 cubed times 4 cubed. times 10 all at one time. Wait, did I do something wrong there? Let's do it again. So 7 to the third. 4 squared is 16. Multiplied by 10. I don't think that's what. So 54, 880, W cubed, Z to the squared. Okay, and then go ahead and do the last 3 and we will check those. Oh, I did 4. So there's lots of different ways you can enter it in your calculator. All right, we can check and see how we did. Okay, and if you're somebody that likes seeing this written out, I had some people in different classes, like they wanted to write out the 7 to the 5th in that step, and you can, that's fine. Okay, I just have to be able to see your 3 rows, and then you're multiplying your columns down. This is another good one to check. Make sure you have W to the 5th, 4th, cubed, squared, 1, none, 5, 4, 3, 2, 1, none, 4, your Z. Okay? All right, so you have your assignment is like here. So you have to apply the 5 to both the 7 and the W. So that's why it has to be applied to the full term. So it's 7 to the 5th and W to the 5th, and that'll be the same. Yeah, it does, like an unknown value. Yeah. Okay, and then of these problems here, only 1 through 5 are going to be no calculator, okay? So 1 through 5 are no calc, and the rest you can use your calculator.